Hello everyone, this is Mustafa from the Code Show, and today we are going to solve another backtracking problems. Two problems actually from LeetCode, problem number 39 and problem number 40, combination sum and combination sum 2. They are actually pretty similar. It's a very slight difference between them. So we are going to solve both in the same video. You can skip in whatever you want to watch it. And let's start with number 39 first. The problem actually has a pretty simple description that you have, or a pretty simple statement. You have an array of numbers, and you need to and you have another argument called target. You need to find all possible combination from this array to reach this target. The only constraint here is that you need to find only the unique combination to reach this target. So for example, here um, you only pick 2 2 3 and not 3 2 3. So actually you need to find only one of them. So that's the only constraint here. Actually, this problem is pretty similar to the permutation problem that we already solved together, and yeah, it's pretty easy. We need to find all the possible permutation or possible passes to get to reach this target. So let's start with, as we always do, let's start with defining two arrays. Array result. This is a result array. At the end we will return this array, and another one called pass for the current pass. Okay, and we just need to define our recursive function. Let's call it the DFS. Okay, and this function will take only one argument. This argument is the target, and we will return the result array at the end. For simplicity, we were going to solve this problem in two steps. The first step actually to get all the possible combination or all the possible passes, and after this we will do some pruning to our solution, just to return only the unique passes. Okay, so the current code will just only return all the possible passes, not the correct solution, but after that we will refine it and return only the unique passes. Okay, so let's start define our function, our recursive function. DFS will take only the target. Okay, and base case we need to define the base case. The base case here is if the current target equal 0. That's it, we already reached our goal. We need to push the current pass to the result array. Okay, and we need to return. Let's start for the recursive part. So for the recursive part, we need to check every single item in the candidates array or the given array here, and check it if we can use it or not to reach this target. Okay, so let's define a simple for loop. Okay, let I equal 0, and yeah, I is less than the candidates array. Let's do this length, and we will increment the counter, and for each of them we will need to check if the current candidate larger than the target we already have. If big larger than the target, so if we subtract it from the target we will have a negative value, so it will mess up our solution, so we will skip it. Okay, continue, and let's do the backtracking blueprint. Here do recurse undo. It's pretty simple, so if we need to push this item to the current pass array. Okay, and we need to recurse and update the target. So if target minus the candidate I, so we already backed it, so we need to decrement the current candidate from the target, and to undo what we already did we need to pop this candidate from the pass array, so pass dot pop. Okay, and that's it. This solution will return actually all possible bosses. So let's run this code and see the result. So yeah, as we expected, this is the output is returning all the possible bosses, not the unique one. Okay, so here you find 232 and whatever, so it's bit is the same but it's not unique, so we need only to get the unique items or the unique bosses. Okay, to do so we need to add another argument to the current function. It should be the index, and the index of the current candidate we already started with. So here we send the index, okay, and start our loop from this index. Okay, so we don't start from the beginning of the array each time we do the recursion call. Okay, so this be index, and yeah, I think that's it. Let's run the code again. Maybe I made something here. Yeah, we forget to send the index also here. Let's run code again. DFS, all DFSs are having the indices, and yeah, it's not the index, actually it should be I, the current index. Yeah, that's it. Let's submit it. Yeah, working fine. Yeah, so for the other problem, the next one, actually it's the combination sum. It's pretty similar to we already solved it here. So the only difference actually is each number in the candidates should be used once. Okay, so we cannot, like here, we cannot use 2 twice. Okay, you just need to use the number once, but here in the description you can use it unlimited number of times. Okay, so this is the only refine, or the only thing you need to add or to change in this problem. So let's use this solution. Okay, and we need to do just a small refinement. Okay, so the refinement I want to sort the array so we can skip the if we already use numbers, so we cannot use it again, and we need to add a small if condition, an extra if condition in the recursive call. So if we already used this number, we don't use it again, and we continue to the next step. Okay, so let's sort the array first, and here candidates, yeah, it's a pretty difficult word to have. Okay, sort, and it will take two arguments, a and b, and we should return a minus b. Okay, that will sort our array, and the extra if statement that will help us to skip if you already used this number is that let's add the condition here. Actually, we can add it directly here, but let's add it in a separate if statement just for simplicity, okay, or for readability. Yeah, and if the current I is the current index, sorry, is larger than the index we already having from the recursive function, we need to check if the candidate, okay, of I is equal to the previous candidate we already used, so I minus 1. If yes, we need to continue and skip this index actually. Yeah. Also, one thing here, so we need to increment the current index so we don't use it again. So yeah, we need just to make sure that we are going to the next index. Okay, so that's actually the difference between them. Yeah, that's working fine. Let's submit it. Okay, we have an issue here. Yeah, I find the typo. It's here. Should be 1, not I, actually. So let's run a code again. Yeah, it should work fine right now. So yeah, that's basically it. If you have any questions or anything, just let me know on the comment section below. Thank you. See you later.